All right, so number 6 here on 6.3, number 6, 8, 10, and 12 are all reference angle stuff. So I'll run through the majority of those. I go through a couple of examples of reference angles over here on the right side of the screen. That red part would be the reference angle, and the blue part is going to be the angle that they give you, okay? Reference angle is really how far away an angle is from the x-axis, depending on what quadrant it is in. Okay, so in that first picture, it's in the second quadrant, and so it's just that little distance to the x-axis. And then the only thing that's really different is if it's in the third quadrant. Okay, that bottom picture on the right just kind of shows that it's only that distance there. And so we just have to figure out how to find those distances, right? So I draw that picture, 175, that's the angle, and then that red part is the reference angle. The blue part is all of 180, so we just have to take 180 minus 175, and that gives us the red reference angle. So on B number, we have 310 degrees. So the blue part shows there's, 360 degrees would be all the way there. So subtract 310 and you'll get that little red part that's remaining, and that's our reference angle, 50. So when they give you a really big number, just go ahead and find the coterminal angle, okay? And I kind of run through that here and show how they're pretty much exactly the same. So we went 360 there, and then we went 720 there, and then we have to go another 10 degrees, right, to get to 730. So 2 times around would be 720, and then we just have to go that extra 10 degrees to get to 730. And look at that. That's exactly what we said it would be, 10 degrees, because we basically tried to find the reference angle, and that told us that the reference angle, I'm sorry, we tried to find the coterminal angle so that we could find basically the reference angle in easier terms, right? Hopefully that all makes sense there. Pretty straightforward, but I can see how it is kind of confusing. Okay, so number 8 here, we're just running through more of these examples. So 99 degrees, right? We're gonna go 90 degrees would be to the top, and we'll just go a little bit past that. 99. Okay. So that's about 99 degrees. So we need to find that reference angle there, the red part. So the blue is, that's a whole 180. Then we just have to subtract away the 99, and that gives us what's left in red, the 81. So our reference angle would be 81. So with negative numbers, remember we go counterclockwise instead of we go clockwise instead of counterclockwise. Okay, so we start and we go from the bottom over. So it would be negative 180 to that x-axis and then an extra 19 degrees or whatever, right? So we just have to figure out, what is that extra part there? So obviously, 199 is that whole black part, and we just want the red part, so we have to subtract away the blue part, right? And that gives us 19. Okay. So basically, we're using our unit circle, and it's pretty straightforward. Like for the unit circle, we're going to need to use that for number 10 and 12, just because those are in radians, right? So we'll have to use the unit circle to see where that angle is, and then from there we can find the reference angle. But again, pretty straightforward on those. Oh, and also just remember that we have for radians, that's pi is, 1 halfway around, and then full way around is 2 pi, right? So if it's smaller than pi, like 5 over 6 pi for 10a, you know that is going to be on the top half, right? And it's going to be in the second quadrant, so you're able to figure it out from there. You could just do pi minus 5 pi over 6 for 10a. So all that stuff is pretty straightforward. Okay. You're just finding that little extra bit that we need to get to the x-axis from where the angle stopped. Okay. Alrighty. Okay, so number 15 here. So for all of these, we need to know these things, right? We need to know how to change things around to get it in terms of other things that we can solve more easily. So secant is the same thing as 1 over cosine. Tangent is the same thing as sine over cosine. Okay. Then we have cotangent, which is the same thing as 1 over tangent. And then we have cosecant, which is the same thing as 1 over sine. Okay. So we use all of these things to solve the rest of these, right? So they give us tangent of 330. Well, it's tough for us to find the tangent of 330 without a calculator. So we can change the tangent of 330 into the sine of 330 over cosine of 330, right? Because we have that rule. The tangent is the same thing as the sine over the cosine. So let's use that. So we use that rule, and then from there we can just go to our unit circle, okay? So we go to our unit circle and we find on there that angle 330. So there's that angle 330 right there. All right. So we find that on our unit circle, and we see that the terminal point is radical 3 over 2, negative 1/2. And remember, terminal points go cosine and then sine. So we just figured out that the cosine, or I'm sorry, the sine of 330 is negative 1/2, and the cosine of 330 is radical 3 over 2. Okay, so whenever we're dividing fractions, it's the same thing as multiplying by the flipped, the reciprocal. So that's what I'm doing right here in this step. Those 2's go ahead and cancel out, and we're just left with negative 1 over radical 3. Okay, so pretty straightforward. You change the tangent or whatever you're given into something that you do know, like sine or cosine, and then we just look on our unit circle and find where that is, and then use the terminal point because that's the sine and the cosine.